Hello students, welcome to Shri classes. Let us start lecture number 4, acid species and salts. In last class we discussed about two salts, common salt and calcium oxychloride, which is also called a bleaching powder. And also we saw the application of common salt in production of sodium hydroxide, which was a chloralkali process that was explained in detail. So let me take you through the rest of the salts today. We'll complete that one. Next is baking soda, third salt. It is baking soda. Common name is baking soda. Chemical name is sodium hydrogen carbonate. This is a chemical name. It is also called sodium bicarbonate. It is also called sodium bicarbonate. Chemical formula NaHCO3. NaHCO3. Preparation. How it is prepared? It is prepared when sodium chloride solution reacts with carbon dioxide and ammonia. That means when sodium chloride solution, reaction between sodium chloride, a solution of a sodium chloride and ammonia and carbon dioxide. When I say a solution of a sodium chloride, I am here taking as NaCl plus H2O. So a sodium chloride solution, NaCl plus H2O, when it reacts with ammonia and carbon dioxide, sodium hydrogen carbonate is produced. And one of the products formed is ammonium chloride also. So let us see how is the preparation. It is prepared by reaction between sodium chloride solution and carbon dioxide and ammonia. So what are the chemical reactions? Sodium chloride solution plus carbon dioxide plus ammonia, NH4. This gives you NH3, not ammonia. This gives you ammonium chloride, NH4Cl plus NaHCO3. 4 plus 1, 5. It is balanced, isn't it? NaCl plus H2O plus CO2 plus NH3, ammonium chloride plus sodium hydrogen carbonate. What is this compound? This is what we require, salt, and this salt is nothing but sodium bicarbonate. Sodium bicarb. Sometime also we simply call this as a sodium bicarb or sodium bicarbonate. Both are okay, either bicarb or sodium bicarbonate or sodium hydrogen carbonate. This is a chemical reaction, how it is prepared. Now uses. What are the uses of baking soda? See, first of all, we use baking powder in our domestic applications, in our household, for the preparation of the the cakes, etc. in home. We use baking powder. For idli maavu and all also we use baking powder. So first of all, I'll say it is used in the preparation of baking powder. First one, preparation of baking powder. So baking powder, it is a mixture of sodium hydrogen carbonate, which is a baking soda, and also mild edible acid. Mild edible acid is tartaric acid. So these two put together we call a baking powder. You understand? So this is the first this thing. See, important thing is, whenever this baking powder is used in say for example in preparation of the cakes or bread and all, the bread or the bakery products sometimes become soft and spongy and fluffy, isn't it? So what is that causes them soft and spongy in case of bakery items? See, whenever this baking powder is added to the dough and whenever it is heated during cooking, sodium bicarbonate undergoes this reaction. NaHCO3 undergoes a thermal decomposition reaction when it is heated. What are the products formed over here? It will form NaHCO3, Na2CO3, sodium carbonate, Na2CO3 plus CO2 plus H2. Isn't it? So NaHCO3. So here I should have 2 NaHCO3 after heating Na2CO3 and CO2 plus H2. 2 carbon, oxygen, 3 plus 2 plus 1. R 6. It is balanced. So remember, the baking powder majorly it contains baking soda. So whenever it is added to some bakery products and all, bakery dough, and when it is heated to prepare either cakes or breads and all, sodium bicarbonate which is present in the baking powder undergoes a thermal decomposition reaction to produce Na2CO3, carbon dioxide and water, and this CO2 makes the dough to rise, and therefore you can find the bakery products are soft and spongy. So this is the first application. What is the second application? See, this baking soda is a mild, basic, non-corrosive salt. It is a non-corrosive, mild, basic salt, and because of this one we can use this as an antacid. ANTACID, antacid. Why do we use baking soda as an antacid? Or also we can say, in the preparation of certain antacids, baking soda is one of the ingredients because of its mild, non-corrosive, basic in nature. During indigestion process, the acid produced is more in quantity, and therefore we feel acidic nature in our stomach, which causes irritation and pain. If more acid is produced in the stomach, we feel acidity, and that causes some kind of irritation and pain. So when we take antacids, because of its alkaline nature, it will neutralize the action of acids, and thereby it gives relief, and therefore it is used as one of the ingredients in antacid. Also, important thing is to make cooking faster. Baking soda is used. Also to make pakoras crispy. These are some of the applications. Few more important things, 1, 2, 3, and fourth one. What else we can use it? See here, it is also used as soda acid fire extinguisher. Very important. It is used in soda acid fire extinguisher. Why it is used as a why this is used in soda acid fire extinguisher? As the name suggests, soda means here baking soda, which is nothing but NaHCO3 plus, what is acid here? This acid is nothing but sulfuric acid, H2SO4. So you already know how these carbonates and metal bicarbonates react with acid. They produce salt, CO2 and water. Here salt will be sodium sulfate, Na2SO4 plus CO2 plus water. Okay, now it is not balanced here. Let me balance it. Yeah, now I think Na2SO4 CO2 plus H2, 2H plus 2H, 4H, therefore 2H2. It is balanced now. And 4 plus 2 6 plus 2 8 10. So check here now, it is balanced. 2 carbon, it is balanced. So Na2SO4 plus 2 CO2 plus 2 H2. Important thing is why it is used in soda acid fire extinguisher. This CO2 has got a specific property of extinguishing fire. This is the one which extinguishes the fire. Hence it is used in soda acid fire extinguisher. So these are some of the applications of baking soda. And very important is antacid. Why do we use this as an antacid? Is because of its non-corrosive, mild, basic character. It is used in antacid. What else is there? Anything else is there? Let me check up. For making baking powder, sodium hydrogen carbonate as an ingredient in antacids, and soda acid fire extinguisher, and used in kitchen for, yeah, you will be directed to the PPT now, and please make a notes. Here, okay, so here all the details have been given. Very important preparation, you please follow the textbook chemical equations and reactions, and that is my advice to all of you. So when sodium chloride solution is treated with ammonium carbon dioxide, sodium bicarbonate is produced. These are the applications. Please note down the contents. Okay, so can we go to the next salt now? I'll erase this. Before we go to the next salt, we should know a little bit about water of crystallization. Water of crystallization. So how do you define the water of crystallization? Basically, it is defined as fixed number of water molecules present in one formula unit of a salt. So what is water of crystallization? Fixed number of water molecules present in one formula unit of a salt is called the water of crystallization. Important thing here is, see, if I take copper sulfate into 5S2O, this is called hydrated salt. It is called hydrated salt, and it is in the form of crystal. It is in the form of crystal because of the presence of, it is in the form of crystal because of the presence of 5 numbers of water molecules as water of crystallization. As the name itself suggests, for the crystallization, the number of water molecules required are called water of crystallization. So if we add 5H2 to the copper sulfate, it will become a crystal, and its color will be a blue color. This is also called blue vitriol. And it is in blue color. Now, if it is heated in a test tube, you take copper sulfate, hydrated copper sulfate crystals here, okay, and heat it. Okay, if we heat this one, what happens? This blue copper sulfate turns to white powder. What is that it loses? It loses water of crystallization molecules. What we have taken here earlier, these are CuSO4 into 5H2O, which is hydrated copper sulfate or blue vitriol, or copper sulfate which is in blue color, blue crystals we had taken. And now if it is heated, it will lose either partially or fully the water of crystallization molecules and forms and gets converted into a white powder. And this property, generally for this happens to many of the salts. Say for example, I can take something like, first let me write the reactions here. Copper sulfate, CuSO4 into 5H2O. So what happens if you heat it? It will become CuSO4 plus 5H2O. This is called anhydrous salt. And this is called hydrated salt. So whenever these hydrated salts which contain fixed number of water molecules as a water of crystallization generally will be in the form of crystals. The moment they lose water molecules, they can lose water molecules if they are exposed to atmosphere or if those are heated. By losing fixed number of water molecules, they will be converted into anhydrous salt. Please remember, from crystals to the powder is the change. That means what is the change that is observed is, here these are crystals and here it is a powder here. This process or this phenomenon of loss of crystallization molecules, water of crystallization molecules by means of heating or when those are exposed to atmosphere, this phenomenon is called efflorescence. This phenomenon is called efflorescence. EFFLORESCENCE, efflorescence. So what is the phenomenon efflorescence? Efflorescence is a phenomenon in which when the hydrated salts are exposed to atmosphere or when the hydrated salts are heated, they lose water of crystallization molecules either partially or completely and turn into powder form. See, very interesting, no? When they absorb, once again, if they absorb the hydrated anhydrous salts, when they absorb water molecules, they will get converted into crystals and a particular color also will be imparted. The same thing with the ferrous sulfate crystals also. We have seen the ferrous sulfate pale green colored ferrous sulfate crystals. When those are heated, Fe2O3, SO2 and SO3 gases are produced. So first it will lose water of crystallization molecule and gets converted to powder. So ferrous sulfate are green crystals. When those are heated, it will lose water molecules, fixed number of water molecules, and get converted into powder. Further heating make it to undergo thermal decomposition reaction, which you have studied already. So here also copper sulfate, when it is heated, it will lose water of crystallization molecule and gets converted into anhydrous salt, which is a powder, and this phenomenon is called efflorescence. And this phenomenon of heating and converting crystals to efflorescence is observed in many of the hydrated salts. One more is magnesium sulfate into 7H2O, and this is called Epsom salt. Epsom salt. And let me take the examples of your textbook. What are the examples of the textbook hydrated salt? For example, gypsum. Gypsum. What is the formula of the gypsum? Calcium sulfate into 2H2O. And also plaster of Paris is there, or also washing soda is there. Washing soda. What is the formula? Na2CO3 into 10H2O. So all these are the crystals here. Washing soda, calcium sulfate into 2H2O, which is a gypsum, and magnesium sulfate into 7H2O, Epsom salt, copper sulfate, etc. So water of crystallization, you have understood, fixed number of water molecules present in one formula unit of a salt is called water of crystallization. When the hydrated salts lose water of crystallization molecules, they get converted into powder, and that phenomenon is called efflorescence. So why did we study this one? That means very interesting to inform you that these substances are there in the form of crystals by absorption of water molecules. Is it not interesting? By absorbing the water molecules, actually they could have dissolved, isn't it? This is what generally we observe. For example, so what I can say here is these are the substances, salts. When they take water molecules, they form the crystals, and that is very interesting. So with this, let me proceed to the next salt, okay? Because next salt what we are going to see is washing soda and its formula and preparation, and is this. Let us see now. So next is washing soda. This is a fourth salt, fourth one, washing soda. Washing soda is the common name, or also it is called the commercial name. What is the chemical name for this one? Washing soda chemical name is sodium carbonate. Sodium carbonate decahydrate. So what is the chemical formula for this one? Chemical formula for this one, as the name suggests, it is decahydrate, means 10 number of water molecules and sodium carbonate, Na2CO3 into 10H2. The dot here indicates into. We call this as into. So Na2CO3 into 10H2O is the chemical formula of sodium carbonate decahydrate, and the common name for that is washing soda. So how this is prepared? Preparation. How this is prepared? In order to obtain sodium carbonate, first we should heat baking soda. Do you understand? There are two steps, very simple steps. First, obtain sodium carbonate by heating baking soda. What is baking soda? Sodium hydrogen carbonate. So by heating baking soda, we obtain sodium carbonate, and then crystallize it. How do you crystallize? By adding water molecules. Anhydrous salts will get converted into hydrated salts, isn't it? So for that sodium carbonate which is produced, you add water molecules, and addition of that water molecules for sodium carbonate is called recrystallization. It is called recrystallization. So there are two steps here. The first step is obtain Na2CO3 sodium carbonate by heating baking soda. Obtain Na2CO3 by heating baking soda. NaHCO3, when it is heated, already you know this reaction, Na2CO3 plus CO2 plus H2O. Is it not the reaction? Balances 2 NaHCO3, 2C and 2H. It is balanced. Now second step is recrystallization of sodium carbonate to obtain washing soda. Washing soda is obtained by recrystallization of what is that? Sodium carbonate. So Na2CO3 plus 10H2O gives you Na2CO3 into 10H2. So these are the two processes, or the two-step process, that is to obtain sodium carbonate into 10H2O, which is nothing but washing soda. Washing soda. Is it clear? Let us study the applications of this one. What are the uses here? Preparation, you have understood. Uses. One of the important uses that I would like to highlight, which as well as comes in the exam, is, see, it is used to treat the permanent hardness of water, or it is used for softening of hard water or softening of water. So first application is for the treatment of permanent hardness of water. Treatment of permanent hardness. For treatment of water, I will say, see, you can note on you can make the notes in detail. I am briefly writing here. Treatment of water to remove permanent hardness. This is used. And the second application, it is used in the manufacturing of glass, soap, paper industries. So very wide application in industries, glass industry, soap industry, paper industries. In one or the other form, washing soda is used. Third is, it is used in the manufacture of borax. Borax also is one of the such a sodium compound which is very widely used in industries. And fourth application is what else is there? Let me check up. Cleaning agent. Finally, in our household applications, we use it as a cleaning agent. Cleaning agent in domestic applications. In domestic applications. These are the uses of washing soda. Okay, so now you'll be directed to the PPT. Note down the detailed notes. Here I hope these reactions are clearly visible to you. Of course, these are the reactions from the textbook, but note down all the details. Yeah, now we look at the next one, the plaster of Paris. Let us see on the board here, Fib salt, plaster of Paris. It is also called POP, plaster of Paris. It is the common name. What is the chemical name for this one? Calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Chemical formula CaSO4 into half water molecule. Only with half water molecule, plaster of Paris is formed. And nature, how it looks like? It is a white powder. Okay. How it is obtained? When we heat gypsum, gypsum will get converted into calcium sulfate into half H2O. So when gypsum is heated to 373 Kelvin, it will lose its water of molecules, 1.5 water molecules, and it will form plaster of Paris. What is gypsum basically? Let us see here. By heating gypsum, we obtain plaster of Paris by heating preparation. By heating gypsum, at 373 Kelvin. So how much is 373 Kelvin? 100 degrees Celsius, correct? No, 273 Kelvin is 0 degrees Celsius and 373 Kelvin is 100 degrees Celsius. So by heating gypsum at 373 Kelvin, we obtain plaster of Paris. So what is the formula for this gypsum? I'll write here. This is calcium sulfate. Just a minute, here write. Calcium sulfate into 2H2O is called gypsum. It is also hydrated salt. When it is heated to 373 Kelvin, it will get converted into CaSO4 into half H2O, which is plaster of Paris, and 2 molecules here and half molecule. So how much? 1.5 is left. 1.5 molecules of water. So by loss of 1.5 molecules of water, gypsum will get converted into plaster of Paris. So this is the manufacturing method here. Next is, what are the applications here? Applications of plaster of Paris or uses of plaster of Paris. First thing, it is used as a plaster or plastering by the doctors. It is used for the plastering the fractured bones. It is used for plastering the fractured bones to keep them in position. You understood? The fractured bones, if those are to be kept in position and once again to be joined, then we use the plastering material. This plaster of Paris as the plastering material, we use it. So what happens during this process? See, whenever this calcium sulfate CaSO4 into half H2O. If water is mixed for this one, okay, this is POP. And what do the doctors do here? They take plaster of Paris and mix water in that one. So once again it will form a gypsum here, which is a hard solid mass called gypsum. CaSO4 into 2H2O. So actually plastering means they will mix water into the plaster of Paris. It will become a hard and set mass, hard and solid mass. It will set there, and therefore it would be able to keep the fractured bones in position for a longer time, so that the bones will get rejoined once again by development of the bone cells. First one. Second one, POP is used in manufacturing in manufacturing of decorative articles. Also it is used for smoothing the surface, and also it is used in the it is used as a decorative articles in smoothing the surface. And what else? It is also used in making toys. Important. Making toys. These are some of the applications. You must remember here, calcium sulfate, if it is heated, plaster of gypsum, if it is heated, plaster of Paris is produced. For a plaster of Paris, if you add water, then a gypsum is formed. So you must remember these two things here. And applications are decorative articles, for plastering, for smoothing of the surfaces, for making of the toys. I hope you have understood. Note down the notes from the PPT now. You will be directed to the PPT. And calcium sulfate hemihydrate. Remember the formula for plaster of Paris is CaSO4 into half H2O, which is called hemihydrate. Now question comes, what is the name of this gypsum here? Gypsum is a common name. What is the chemical name? Chemical name is calcium sulfate. How many water molecules are there? Di. Therefore it is called dihydrate. Calcium sulfate dihydrate is the name of the gypsum. Please remember that. I have not written here. But what is the chemical name of calcium sulfate into 2H2O, or what is the chemical name of a gypsum? Gypsum is a common name. Chemical name of a gypsum is calcium sulfate dihydrate. Okay. Yeah, rest of the things, please make a note of this. Yeah, here this is the end of the section here. Are the crystals of salts are really dry? Isn't it the same question? Crystals are really dry only, but how they become dry? By absorbing the water molecules, fixed number of water molecules, they become dry, and then they are in the form of crystals. So this one small experiment and all it is given, which I have already explained to you. And if you want, you can note it down, or at least you should note down the definition of water of crystallization out of this experiment. This is the activity which I already discussed, and here we complete the chapter. Now let us go through the question answers of the textbook. In text and out text questions we'll solve it now, okay, and then I'll take you through the exemplar questions. Okay, let us go through in text and exercise questions. The in text questions, the first question: you have been provided with 3 test tubes. One of them contains distilled water, the other 2 contain an acid and a base. If you are given only red litmus paper, how will you identify the contents of the test tube? 3 test tubes are there, ABC, contains water, acid and base. What is that we have been given? Only red litmus paper. How do you identify all these 3? Take the red litmus paper, put into the first solution. If it turns to blue color, then it is a basic solution. First is over. Take that blue color, next you put into one more test tube. If it turns to red color, then blue to red, the next test tube contains acid. Then it turns blue to red, therefore it is acid. Take the same litmus paper which is reddish in color, put into one more test tube. If there is no change, then it is a water. So this is how you can identify with a single litmus paper all the 3 contents, whether those are, which one is acid, base or a water. Okay, let's go to the next one now. here. Let's read this. Why should curd and sour substances not be kept in brass and copper vessels? Curd and sour substances such as pickles contain acids. When those are kept in brass and copper, they react with metals to form poisonous salts, and which make the substances unfit for consumption, and hence curd and sour substances such as pickle should not be kept in brass or copper vessels. Which gas is usually liberated when an acid reacts with a metal? Illustrate with an example. How will you test for the presence of this gas? You have to describe an activity also there. So which gas is usually liberated when an acid reacts with a metal? Hydrogen gas is liberated. So illustrate with an example. Take zinc granules in a test tube, add sulfuric acid to this one, and the gas liberated is made to pass through the bubble soap solution, and the gas forms the bubbles. Whenever a burning matchstick or a candle is brought near the bubbles, it will burn with a pop sound. Thereby it ensures that the gas liberated is hydrogen gas. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. When effervescence is, I hope you must have already concluded, effervescence means the rapid evolution of gas. So you must have got the answer also now. A metal compound A reacts with dilute HCl and to produce effervescence. The gas evolved extinguishes a burning candle. So definitely it must be carbon dioxide. Is it not? It produces an effervescence and it extinguishes a burning candle. It extinguishes a burning candle means it is carbon dioxide gas. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. Let me write this chemical equation here. As one of the chemicals formed is calcium chloride, what is the chemical equation? So tell me, carbonate of calcium is the metal here, is it not? So write the chemical equation. He says metal A is calcium carbonate here, CaCO3, calcium carbonate, plus which gas, which acid? Dilute HCl, hydrochloric acid, results into CaCl2 plus CO2 plus H2. So this is 2HCl, CaCl2, CO2, H2. Correct, it is balanced. So what is this metal A? Not metal, compound A. Compound A, this is compound A, is calcium carbonate, because one of the products formed is calcium chloride. So carbon dioxide is the evolved gas which extinguishes the fire. This is the chemical equation for the reaction. Next question. Here, why do HCl, HNO3, etc. show acidic characters in aqueous solutions, while solutions of compounds like alcohol and glucose do not show acidic character? H plus ions are responsible for showing acidic character, and therefore HCl and HNO3 in aqueous solutions, they release H plus ions, which is responsible for acidic property, and hence HCl and HNO3 show acidic characters. Whereas compounds such as alcohol and glucose, even though those contain hydrogen atoms, they will not dissociate into the ions to produce H plus ions in aqueous solutions. Hence, they do not exhibit acidic character. Why does an aqueous solution of an acid conduct electricity? An aqueous solution of an acid contains H plus ions or hydronium ions, H3O plus ions, and ions are responsible for conduction of electricity. Why does a dry HCl gas not change the color of the dry litmus paper? dry HCl gas cannot undergo dissociation to produce H plus ions, and hence it does not exhibit acidic property, hence it will not change the color of the dry litmus paper. Whereas if you take the wet litmus paper, in the presence of water, HCl undergoes dissociation to produce H plus ions, and that exhibits acidic character, so the blue litmus will change to a red litmus. Next, while diluting an acid, why it is recommended that acid should be added to water and not water to the acid? Dilution process of an acid is highly exothermic in nature. Always acid should be added to water slowly and with constant stirring. Otherwise, if water is added to acid, the excessive heat produced may result into the breakage of the apparatus, or also due to highly exothermic nature, the mixture may splash out and causes the severe burns to the acid handler or the person who handles. How is the concentration of hydronium ions affected when a solution of an acid is diluted? The concentration of hydronium ions per unit volume decreases when a solution of an acid is diluted, isn't it? How is the concentration of hydroxide ions affected when excess space is dissolved in a solution of sodium hydroxide? Already there is a sodium hydroxide solution. You add, how is the concentration of hydroxide ions affected when excess base is dissolved? Already sodium hydroxide solution is there. You add additional base such as sodium hydroxide. What happens? Sodium hydroxide, whenever you add to a solution, it will dissociate into hydroxide ions. So the concentration of hydroxide ions per unit volume increases here. That is the answer. Let us go to the next set of questions. Here. You have two solutions A and B. pH of A is 6, means acidic. pH of solution B is 8, means basic. Which solution has more hydrogen ion concentration? Acid solution will be having more hydrogen ion concentration compared to the base solution. So solution A has got more hydrogen ion concentration. Which of this is acidic and which one is basic? Solution A with pH 6 is acidic. Solution B with pH 8 is basic. What effect does the concentration of H plus ions have on the nature of the solution? What effect? As the concentration of H plus ions increase, the acidic character increases. That is the effect of H plus ion concentration on the effect of solution. Next. Very important question. Do basic solutions also have H plus ions? If yes, then why are these basic? Yes, first question is yes, basic solutions also have H plus ion concentration, but hydroxide the number of concentration of hydroxide ions is much high compared to H plus ions, and hence it shows a basic character, isn't it? That is the answer. Under what soil condition do you think a farmer would treat the soil of his field with quicklime? Quicklime means calcium oxide, slate lime, calcium hydroxide, or chalk or calcium carbonate. Quicklime calcium oxide is a metal oxide. Metallic oxides are basic in nature, which you have already studied. So this is basic in nature. Slate lime calcium hydroxide solution releases hydroxide ions and therefore it is a base. Calcium carbonate. Calcium carbonates are also basic salts. Calcium carbonate is a basic salt. The nature of all these, if you see the salts here, are bases, and therefore under what soil condition do you think a farmer would treat the soil with the bases? When the soil condition is acidic in nature, then he will treat with quicklime or slate lime or calcium carbonate in order to neutralize the effect of acid, because otherwise it will affect the acidic nature of the soil, may affect the crop production. So if the soil condition is acidic in nature, then the farmer would treat the soil with calcium oxide, slate lime or calcium carbonate to nullify the effect of acid. Next one. Here we have questions. What is the common name of the compound CaOCl2? Common name of the compound CaOCl2 is, what is that? Calcium oxychloride. So bleaching powder is the common name for CaOCl2. Name the substance which on treatment with chlorine yields bleaching powder. Dry slaked lime is the substance on treatment with chlorine yields bleaching powder. Name the sodium compound which is used for softening hard water. Washing soda is the substance used for softening the hard water. What will happen if a solution of sodium hydrogen carbonate is heated? Give equation of the reaction involved. What will happen in a solution of sodium hydrogen carbonate? Sodium hydrogen carbonate will undergo a thermal decomposition reactions to produce Na2CO3 plus H2O plus CO2, isn't it? That CO2 is the one which is responsible for making the bakery products soft and spongy also. Okay, that is the reaction. You can write the reaction which I have already given. Write an equation to show the reaction between plaster of Paris and water. CaSO4 into half H2O plus 1 and half H2O gives you CaSO4 into 2 H2O, which is the gypsum. So this is also quite simple. Yeah, let's go through the exercise questions here. Let's go to the exercise questions. I think it should be enlarged further. I think now it is quite clear. It's visible for you. Let me hold the textbook also with me. A solution turns red litmus blue. Its pH is likely to be. Which solution turns the red litmus blue? Alkaline or basic? For base, the value should be above 7 and therefore answer D is the right answer. A solution turns red litmus blue, its pH is likely to be a basic, which is 10. A solution reacts with crushed eggshells to give a gas that turns lime water milky. The solution contains. What is that it will contain? A solution reacts with crushed eggshells. Crushed eggshells contain calcium carbonate. So when that calcium carbonate reacts with one of this one, it turns the lime water, it produces such a gas which turns the lime water milky. Eggshell contains calcium carbonate. Calcium carbonate when reacts with acid, it will produce CO2 and CO2 gas turns the lime water milky. So therefore NaCl no, HCl yes, lithium chloride no, potassium chloride no, because crushed eggshells react with hydrochloric acid to produce a gas CO2 that turns lime water milky. Answer is B here. 10 ml of solution of NaOH is found to be completely neutralized by 8 ml of given solution HCl. For 10 ml NaOH, 8 ml HCl. If you take 20 ml of the same solution of NaOH, the amount of HCl the same as before required to neutralize it will be 10 ml NaOH requires 8 ml of HCl. 20 ml NaOH, double the quantity, 16 ml it requires. Next, which of the following types of medicines is used for treating indigestion? For treating indigestion. Antibiotic used to kill the pathogens. Analgesic as a painkiller. Antacid, this one, for treating the indigestion like baking soda. Antiseptic, it is to decrease the effect of septic of some wounds or the bites. So definitely antacid is the answer for this one. Write word equations and then balanced equations for the reaction taking place. Take this as an assignment because all these reactions I have already discussed in my previous lectures. Next, compounds such as alcohols and glucose also contain hydrogen but are not categorized as acids. Describe an activity to prove it. How do you describe an activity? You have to show the activity of glowing up of a bulb there. Okay, That means alcohols and glucose do not dissociate into ions in aqueous solutions, and hence they do not conduct electricity and the bulb does not glow. Whereas if you take acids such as sulfuric acid or hydrochloric acid, or even if you take bases such as sodium hydroxide, acids will dissociate into ions to produce H plus ions, and bases will dissociate to produce hydroxide ions, and the movement of ions are responsible for conduction of electricity. So acids or bases will conduct electricity and the bulb glows because they produce ions, whereas glucose and alcohol does not produce glucose or alcohol do not produce ions. They do not dissociate into ions, hence they do not conduct electricity and the bulb does not glow. See here, this activity is to be explained with a diagram and all. Why does distilled water not conduct electricity whereas rainwater? Distilled water is a pure water and it produces ions. It will not dissociate into ions, neither it will not contain any ions. Therefore, distilled water does not conduct electricity. Let us see what is a rainwater. Rainwater, see, in the atmosphere you have sulfur dioxide and nitrogen dioxide. How do you get that one? By burning fossil fuels. So, SO2, NO2 are acidic in nature, we have studied already, isn't it? So, they react with bases to form salt and water. So, we have studied that non-metallic oxides are acidic in nature. Therefore, CO2, NO2 present in the atmosphere will react with what is that? Compounds such as alcohols and glucose contain hydrogen. No, here we are talking about rainwater. The rainwater, sulfur dioxide, nitrogen dioxide, which is present in the atmosphere, will react with water to form acids, and these acids dissociate into ions, and those ions are responsible for conduction of electricity. Whereas distilled water is a pure water, it does not contain any ions and therefore it does not conduct electricity. Is it very clear? Next. Why do acids not show acidic behavior in the absence of water? In the absence of water, acids do not dissociate into ions, and therefore they do not produce H plus ions, and hence in the absence of water they do not exhibit acidic property. 5 solutions ABCD when tested with universal indicators showed a pH 4, 1, 11, 7 and 9. Which solution is a neutral? The one which has pH 7. Strongly alkaline, above 7, 11. Strongly acidic, nearer to 0, 1. Weakly acidic, between 7 and 1, 4. Weakly alkaline, between 7 and 11, 9. I hope you have understood all this. Next is, equal lengths of magnesium ribbons are taken in test tube A and B. Hydrochloric acid is added to test tube A, while acetic acid is added to test tube B. Amount and concentration taken for both acids are same. In which test tube will the fizzing occur more vigorously and why? First of all, magnesium ribbon and the reaction between magnesium and HCl, magnesium and acetic acid. We know metals reacts with acids to produce hydrogen gas. Hydrochloric acid being strong acid, it dissociates into respective ions very quickly, and therefore hydrogen gas is liberated at a much faster rate when magnesium reacts with hydrochloric acid compared to acetic acid. Remember, in both the cases hydrogen gas is evolved, but the fizzing should occur. Fizzing means it should come out, something like that. So if that is the case, then definitely hydrochloric acid is a strong acid which undergoes a complete dissociation and the reaction is faster, and therefore magnesium reacts with hydrochloric acid to produce fizzing action of hydrogen gas evolved, okay, compared to the acetic acid. So once again, answer is HCl is a strong acid whereas acetic acid is a weak acid. Hence in the strong acid the reactions of metals and acids is faster, and therefore hydrogen gas produced is with fizzing salt. Okay, next one. Fresh milk has a pH of 6. How do you think the pH will change as it turns into curd? As it turns into curd or a sour, it becomes a sour. It becomes sour, or as it turns into a curd, it contains an acid. What is that acid? Lactic acid, and therefore pH further decreases. Fresh milk has a pH of 6. How do you think the pH will change as it turns into curd? The pH decreases because lactic acid is produced. a milkman adds a very small amount of baking soda to the fresh milk. Why does he shift the pH of the fresh milk from 6 to slightly alkaline? When he shifts the pH of the freshly milk from 6 to slightly alkaline, then the milk will not get spoiled easily because lactic acid cannot form easily, and therefore the milk can be kept for a longer duration without spoiling or without getting converted into sour or without getting converted into curd. Why does this milk take a long time to set as a curd? Because see, the enzymes present in the milk will be able to make the milk sour, but the action of the enzymes is not effective if the medium is alkaline. Are you able to understand? So if a baking soda is added to a milk, it becomes alkaline in nature, and the effect of enzymes present in the milk will not be very effective. The effect of or the enzymes will not act upon the alkaline medium, and therefore curd is not produced, or the lactic acid is not produced, or the milk does not turn into sour. So once again, why does the milk take a long time to set as a curd here? Because enzymes present cannot act on alkaline medium. Plaster of Paris should be stored in a moisture proof container. Explain why. If it contains the moisture, a plaster of Paris can absorb the moisture from the atmosphere and becomes a solid hard mass called gypsum, isn't it? Therefore it should not be stored in it should be stored in a moisture proof container. What is the neutralization reaction? Give two examples. The reaction between acids and bases is called a neutralization reaction. I have given so many equations, you can refer to my notes. Give two important uses of washing soda and baking soda. So all these things have been discussed in detail. Once again, if you want what are the uses of washing soda? Washing soda is used as a cleaning agent in domestic applications. It is used in the treatment of permanent hardness or softening of a water, and baking soda to make the cooking faster, used as an antacid, and to make the pakoras crispy, and it is used in the manufacturing of baking powder, which is a mixture of baking soda and tartaric acid. These are the applications. So I think we have completed all the question answers of your in-text and out-text questions. In my next class, which is the last class, I'll take a few exemplar questions and try to solve them. Okay. Now here one activity is there, very important activity, you can go through. Not the first one, second one. Prepare a soda acid fire extinguisher. Remember, which is used in soda acid fire extinguisher? Sodium bicarbonate, isn't it? Sodium bicarbonate. See here, this is what you can prepare. In this ignition tube, you can take dilute sulfuric acid and here sodium hydrogen carbonate solution. So once if you mix it, sodium hydrogen carbonate will react with acids to form CO2, water and H2O. So this is what you get over here is CO2. You bring a burning candle or a matchstick, it will get extinguished due to formation of CO2 gas over here. So sodium bicarbonate is used in soda acid fire extinguisher, which you can prepare yourself. So this activity is to demonstrate the application of sodium hydrogen carbonate, which is used as a soda acid fire extinguisher, and also to demonstrate the reaction between metal bicarbonates and acids. What is the reaction between metal bicarbonates and acids? To give CO2, water and salt, and CO2 brisk effervescence is produced over here. So this is one activity to demonstrate how sodium hydrogen carbonate can be used to prepare a soda acid fire extinguisher at home. I think I have discussed all the points in your this thing. So let me end the lecture over here and see in the next lecture, and I'll take some exemplar questions from exemplar textbook. Thank you very much for watching.